Hi, mystery investigator. Have you ever pondered the intricate dynamics that unfold when a machine ceases to function? What if I told you that the precise moment you grasp how a machine operates could paradoxically be the very moment it begins its descent into failure? Today, we are venturing into a captivating paradox. Every successful explanation of machine mechanics seems to coincide with an impending total breakdown. So, if you're eager to uncover the hidden truths behind machine operations, ensure you subscribe for more enlightening insights. Machines are engineered to function seamlessly, yet they are far from infallible. The phenomenon of machine failure is well documented in engineering literature, with studies revealing that intermittent failures often precede a complete breakdown. For instance, a report from the National Institute of Standards and Technology, NIST, highlights that nearly 70% of machinery failures are attributed to human error, mechanical wear, or programming discrepancies. These sporadic issues can arise from various causes, including mechanical wear, misalignment, or even programming errors. The irony is striking. The more we dissect and elucidate these failures, the more we expose them to the risk of total collapse. Let's delve into CNC machines, for example. These sophisticated systems have transformed the manufacturing landscape, allowing for unparalleled control over cutting, drilling, and milling processes. However, they are not immune to failure. Research indicates that common issues such as spindle overheating, tool breakage, and programming errors can emerge without warning, leading to significant production downtime. Interestingly, a study conducted by the Society of Manufacturing Engineers, SME, found that improper tool selection contributed to over 40% of tool breakage incidents in CNC machining. It's fascinating to note that while troubleshooting these machines can lead to a deeper understanding of their mechanics, this very knowledge can also highlight vulnerabilities that were previously unnoticed. Consider the spindle, often referred to as the heart of any CNC machine. Overheating, vibrations, and unusual noises are telltale signs of potential failures. Research indicates that these problems often arise from improper lubrication or misalignment, with a staggering 30% of spindle failures linked to inadequate maintenance practices. The moment an operator recognizes these warning signs, they might feel empowered to rectify the issue. Yet, this newfound understanding can inadvertently lead to overconfidence. The operator might push the machine beyond its limits, believing they can prevent failure through sheer knowledge. Ironically, this can result in the very breakdown they sought to avoid, a phenomenon that echoes the cautionary tales of seasoned engineers. Programming errors present another layer to this conundrum. In the realm of CNC machining, even a minor mistake in G-code can lead to catastrophic outcomes. Operators often double-check their code to minimize these errors, yet the more they delve into the intricacies of programming, the more they open themselves up to potential pitfalls. A 2021 survey by the International Society of Automation revealed that nearly 25% of CNC operators admitted to experiencing programming errors that led to machine crashes. The complexity of the machine's operation can obscure simple mistakes, leading to crashes and misaligned cuts. Thus, a successful explanation of how to program the machine can coincide with total failure when the operator becomes complacent or overconfident. In the field of emergency management, a similar narrative unfolds. The Texas Government Code emphasizes the importance of adhering to emergency orders, particularly in high-stakes situations like natural disasters. Yet, those who fully comprehend the regulations might feel a sense of invincibility, believing they can navigate the system without oversight. This overconfidence can lead to misjudgments, especially in critical moments where lives are at stake. For instance, during Hurricane Harvey in 2017, Officials who were well-versed in emergency protocols faced challenges that stemmed from over-reliance on their knowledge, resulting in delays and miscommunications that exacerbated the crisis. Understanding the system is crucial, but it can also breed a false sense of security, resulting in dire consequences. The paradox extends beyond machinery and regulations. It permeates our everyday experiences, revealing a fundamental truth about human nature. Think about it. The more we understand a situation, the more we realize its complexities. This can lead to analysis paralysis, where decisive action is hindered by overthinking. In the context of machinery, a deep understanding can illuminate the machine's weaknesses, making it more vulnerable to failure. The very act of troubleshooting can become a double-edged sword, where knowledge is both a tool and a potential trap. As we explore this paradox further, it's essential to examine the role of predictive maintenance. This strategy aims to anticipate machine failures before they occur by analyzing data and identifying patterns. While predictive maintenance can significantly reduce downtime by as much as 30%, according to a report from McKinsey & Company, it also raises the stakes. The more data we gather, the more we realize the numerous variables at play. This can lead to an overwhelming sense of responsibility, as operators grapple with the knowledge that their understanding could be the difference between a smooth operation and a catastrophic failure. In industries like aerospace and defense, this phenomenon is particularly pronounced. Engineers and technicians are tasked with ensuring the reliability of complex systems, often under immense pressure. A deep understanding of these systems is essential, yet it can also foster an environment where overconfidence thrives. For instance, during the 2018 Boeing 737 MAX incidents, engineers believed they had accounted for every variable in the aircraft's operation. However, this confidence led to critical oversights that resulted in tragic accidents. The relationship between knowledge and failure is a delicate balance that must be navigated carefully, reminding us of the inherent risks of overconfidence. So, what's the lesson here? Understanding a machine or a system can empower us, but it can also expose us to new vulnerabilities. Every successful explanation carries the weight of potential failure. This paradox is not just an engineering dilemma, it's a reflection of human nature. We crave knowledge, yet that very knowledge can lead us down a treacherous path if we are not vigilant. As we unravel the complexities of machines and their failures, we must remain acutely aware of the fine line between understanding and overconfidence. The next time you troubleshoot a machine or navigate a complex system, keep in mind that every successful explanation might just coincide with total failure. If you found this exploration into the paradox of understanding and failure intriguing, don't forget to like, comment, and subscribe for more thought-provoking content. Until next time, mystery investigator, stay curious and cautious.